Hi everyone, here are the answers for exam 3. Starting with problem 1, it was r is 2 plus 2 cosine theta. You needed to complete the graph. In part A, you also needed to complete the table. When theta was 2 pi over 3, the r value was 1. When theta was pi, the radius was 0. When theta was 4 pi over 3, the radius went back to 1. Theta was 3 pi over 2, the radius was 2. And at 5 pi over 3, the radius was 3. Those all worked out to be whole numbers, and I got each of those by plugging in the appropriate angle in here, taking the cosine of the angle, multiplying that by 2, and then adding 2. So I got my table. I expected you to then plot the points over here. The graph was started for you. So if I want to plot 2 pi over 3 with a radius of 1, the angle of 2 pi over 3 is here. A radius of 1 would be that first circle. Pi and a radius of 0. Remember, anytime your radius is 0, you're at the origin. 4 pi over 3 back to a radius of 1. Okay. 3 pi over 2, and you have a radius of 2. And 5 pi over 3, your radius was 3. And if I use that to complete the graph, you see the cardioid shape that was so familiar that we worked with in chapter 10, and that completes the curve. Okay, later you're going to come back and you're going to sketch in places where the tangent line is vertical and horizontal, but for part A, that was pretty much what we had there. Part B is asking us to find where the tangent line is horizontal. If the tangent line is horizontal, then I want the top of the slope formula, which was f prime sine theta plus f cosine theta. And I want to set that to be equal to 0, because if the top of that slope function is 0, then I have a horizontal tangent line. Remember, this is my f of theta. So then my f prime of theta would be the derivative of 2 plus 2 cosine theta, which is negative 2 sine theta. Okay, so I'm going to need that in parts B and C. When I go to plug in, I end up with negative 2 sine theta times another sine theta plus f of theta was my 2 plus 2 cosine theta. Remember to put this in parentheses because you're going to need to distribute in the cosine. Okay, if I distribute here, I'm going to end up with a negative 2 sine squared plus 2 cosine theta plus 2 cosine squared theta is 0. Now, if I want to be able to factor this, I need everything to be in terms of cosine and cosine squared, and right now I have the sine squared. So remember, we would do the Pythagorean substitution. Sine squared is 1 minus cosine squared plus 2 cosine theta, 2 cosine squared. If I distribute and combine like terms, I'm going to end up with a positive 2 cosine squared, and I have another 2 cosine squared, so that's 4 cosine squared plus 2 cosine theta minus 2. And if I pull out the 2 and factor that at the same time, I end up with 2 cosine theta plus 1 and cosine theta minus 1. Oh, sorry, sign switched. This is 2 cosine theta minus 1 and cosine plus 1. Okay? If I set each of these to 0 and solve, I end up here with cosine theta is 1/2, and here I end up with cosine theta is negative 1. Where is cosine theta equal to 1/2? That's going to be at, if it's positive 1/2, I'm looking at pi over 3 and quadrant 1, and 5 pi over 3, or negative pi over 3, which is my quadrant 4. Cosine of theta equal to negative 1, that's going to occur at pi. Okay, so these are the answers that I was looking for part B. These are places where the tangent line is horizontal. Let's look on our graph and see how we see that showing up. At pi over 3 and 5 pi over 3, that's going to be right here and right here. So I was looking for H's here. The tangent line is horizontal. And at pi, that's right here. So another horizontal there where the graph intersects the origin. Okay, that's an angle of pi. Okay, that's 1B. Now let's take a look at 1C. Similar approach, except this is the bottom of the slope function, which is going to be f prime cosine theta minus f sine theta, and setting that equal to 0. When I substitute in f prime and f, I end up with -2 sine theta cosine theta minus 2 plus 2 cosine theta times sine theta is 0. And I'm going to get a little squished here with my past work, so I'm going to erase part of this just so that you can see it. Okay, and I'll draw a line there so it's clear. All right. So, if I distribute here and combine like terms, I'm going to have another -2 sine theta cosine theta. So altogether, I'm going to have -4 sine theta cosine theta minus 2 sine theta. And that gives me a common factor of -2 sine theta, which means that I have 2 cosine theta minus 1 here. And if I set each of these equal to 0, then sine of theta is 0. I mean, I have a -2 here, but when I divide by -2, I end up with sine theta is 0, which happens at 0 and pi. And here I have cosine theta is, sorry, this should have been a positive one there. I apologize. If I distribute here, -2 sine theta times 2 cosine theta gets me -4 sine theta cosine theta, and -2 sine theta times a positive 1 gets me my -2 sine theta. Gotta watch our signs there. That means cosine is -1/2. The reason I knew to pause there is, wait a second, I've already seen cosine be positive 1/2, so I knew something was up. Cosine theta is -1/2. That means my angle is either 2 pi over 3 or 4 pi over 3. Okay? Now, notice that I've seen this before, theta equal to pi. Remember, this always happens at the cusp of the cardioid, and it can't be both vertical and horizontal at the same time, so I use the graph to help me figure it out. Now, it does mean that I've got 0 over 0 there in my fraction, but the tangent line physically itself is not going to be both horizontal and vertical at the same time. And if I look here, if I look at 2 pi over 3, let me put these in black, 2 pi over 3 and 4 pi over 3, there's my verticals. Okay, I also have one at 0, there's a vertical here, but notice that at pi, right, that's where that cusp is, the tangent line is not vertical, it's going horizontal at that point. So I expected you for full credit to X off or not include that point of pi. So my answers here were going to be 0, 2 pi over 3, and 4 pi over 3. Those were the only 3 answers you should have for vertical for full credit. Okay? So that's parts A, B, and C put together. Part D was doing the area, so I'm going to erase what I had for B. Okay, but to do a complete parts B and C, you needed to put in the V's and the H's for horizontal and vertical tangent lines. Let's look at part B to complete problem 1. Part B was to find the area contained on the curve on the interval from 0 to 2 pi, and that area formula is 1/2 times f of theta squared. So that means that I'm looking at 1/2 times the integral of 2 plus 2 cosine theta squared d theta. And if I expand that, okay, some of you pulled out some things beforehand, some of you left it in, either way is fine. If I expand this, I end up with 4 plus 8 cosine theta plus 4 cosine squared theta d theta. Some of you, again, you factored out the 4 here, that's what I did. So if I pull out the 4, then I have 1/2 of 4, and what's left, okay, is going to be 1 plus 2 cosine theta. Now at this point I pause and I say, okay, well if I factor out the 4, I'm just left with cosine squared theta. Problem is, I don't know how to integrate cosine squared theta because of the squared. So I'm going to use the half or double angle substitution here, and this is going to become 1/2 plus 1/2 cosine 2 theta, d theta. Okay, so we made a substitution for the cosine squared with the 1/2 plus 1/2 cosine 2 theta. Now I'm ready to integrate. Half of 4 is 2. Okay, I'm no longer going to write my integral symbol because I'm going to take the antiderivative here. Antiderivative of 1, if I'm doing everything with respect to theta, is theta. The antiderivative of 2 cosine theta is 2 sine theta. The antiderivative of 1/2 theta. The antiderivative of 1/2 cosine 2 theta is 1/4 sine 2 theta. And I'm evaluating that on the bounds from 0 to 2 pi. I plug in, okay, and I end up with 2 pi plus the 2 times the sine of pi, that's 0. 1/2 times pi, that's pi. Sine of 2 times 2 pi, that's sine of 4 pi, that's 0. And then in the second parentheses, I got a whole bunch of zeros, because plugging in 0 for theta, sine of 0 is 0, half of 0 is 0, sine of 0 is again 0. Okay, so what I basically got here is 2 pi plus pi, that's 3 pi, times 2, and I get a 6 pi. So my final answer for 1E is 6 pi. Okay guys, here's problem 2. You were given 2 points. P is 2, -2, 4, and Q is 4, 1, -2. The first thing I asked you to do was plot those points. So if I'm going to plot in 3 dimensions, remember this is my X, my Y, my Z. Here's my axis, my X, my Y, my Z. This is positive on the X-axis, so I go to +2. -2 on the Y-axis, so I imagine going backwards 1, 2 steps parallel to the Y-axis. And then from there, +4 on the Z, I imagine going up 4 steps positive to the Z, parallel to the Z-axis. So up 1, 2, 3, 4, and point, label it in green, point P is about here. If I'm going to do Q, Q is 4 on the X-axis, 1 on the Y-axis, so I'm going forward on the Y-axis 1, okay, 1 step forward parallel to the Y-axis. And then -2 on the Z-axis would mean I would be going down 2 steps, okay, again, parallel to the Z-axis. So your point Q would be located somewhere about here. Okay, and then I asked you to draw in the PQ vector. So I'm drawing a vector from P to Q, and there's your PQ vector. In part B, I asked you to find that position vector PQ. Remember, a position vector is basically relocating PQ so that it starts at the origin. And the way I do that is I subtract 4 minus 2, so that's 2. 1 minus -2, that's 3. And -2 minus 4, that's -6. So the position vector was 2, 3, -6. To find the magnitude of that in part C, I'm looking at the square root of the sum of the squares of my components. So 2 squared plus 3 squared plus -6 squared. That works out to be the square root of 49, or 7. So the magnitude of my PQ vector was 7. In part D, I was looking for a vector with a length of 4 that goes in the opposite direction of PQ. Well, first of all, if I want to get a unit vector, remember, is a length 1, and that means taking my vector and dividing it by the magnitude. So the unit vector for PQ, and you didn't necessarily have to do this in between steps, but the unit vector is take each component and divide by the magnitude. So 2 sevenths, 3 sevenths, -6 sevenths would be my unit vector, but that has length 1. I want something with length 4 in the opposite direction, so I'm basically going to multiply this, right? Length 4 in the opposite direction means that I'm going to multiply everything here by a -4. So that's going to be -8 sevenths, -12 sevenths, and +24 sevenths. And that's what I was looking for in D. You didn't necessarily need to include the unit vector, but just to be clear about where I'm getting these numbers from. Last part was E, and that was the midpoint. The midpoint of PQ is the average of all the components, and it's a point, not a vector. So I add the 2 X components. 2 plus 4 is 6, and I divide by 2, so I end up with 3 for the X component. 1 plus -2, or -2 plus 1 over 2, I end up with a -1/2 for the Y component, and 4 plus -2 over 2, I end up with 2 over 2, or 1 for the Y component. So the midpoint of the PQ vector is the point 3, -1/2, +1. And that's the end of problem 2. All right, guys, here's problem 3. We're given a u vector and a v vector, and in part A, you needed to find the dot product of those two vectors. Remember, dot product means multiplying the components together. So this is 6 times 0 plus -1 times 4 plus 5 times 3. And I got 0, -4, and 15. My dot product was 11. In part B, I was looking for you to say, because the dot product is positive, then my angle is acute. Okay, I'm looking for some reference to it being an acute angle because the dot product is positive. Remember, if the dot product's negative, the angle is obtuse. If the dot product's positive, as in this case it's acute, and if the dot product is 0, the two vectors are orthogonal to each other. In part C, I was looking for you to find the value of theta. We know it's acute, now find it. So we're using the formula that u dot v is the magnitude of u, magnitude of v, cosine theta. That's the dot product formula from 11.3. When I fill in what I know, this is 11. If I find the magnitude of u, that's 6 squared plus -1 squared plus 5 squared, take the square root of that. I ended up with the square root of 62. When I take the magnitude of v, 0 squared plus 4 squared plus 3 squared, and take the square root of that, I end up with a magnitude here of 5. And so I'm left to solve for theta. So theta is the inverse cosine, and we're going to be in degrees when we put this in our calculator, of 11 divided by 5 rad 62. And when you do that, you get an angle of 78.3 degrees. I'm sorry, 73.8 degrees. Okay, or about 74 degrees there. Okay, so that's my angle, which is in fact acute and verified by my guess. I verify my guess that I found in part B. Okay, part D is looking for the scalar of u onto v. That formula is u dot v over the magnitude of v. I have everything I need, I just need to plug that in. U dot v was 11, scalar of v was 5, so the scalar was 11/5. That's the length of the projected vector. In part, not E, yes, E. I wanted you to find the actual projected vector of u onto v. That's this u dot v over the magnitude of v, the scalar, multiplied by the unit vector for v. Okay, so this gets me my 11/5, I already found that, and then the unit vector for v is the v vector divided by its magnitude, which was 5. So that's 0 over 5, you could have just written that as 0, 4/5 and 3/5. And I could pull out the fifths if I wanted to. You could write this as 11/25 times the v vector. You could have distributed in as well and called it 44/25 and 33/25. Any of those three answers would have worked. Okay, and that's problem 3. All right, guys, here's problem 4, our plane traveling in 3D. We have a plane that's traveling south at 500 miles per hour. Remember, if I set up my 3D, my x-axis is east and west, my y-axis is my north and south, and my z-axis is my vertical up or downdraft, updraft in this case. Okay, so I've got a plane that's traveling 500 miles per hour south. That means that it's traveling backwards in the y direction. So that vector is going to be 0, -500, 0. Okay, for my crosswind, the crosswind is a horizontal crosswind blowing northwest at 80 miles per hour. Well, northwest would be directly splitting, right, the north and west, the x and y axis there. I'm going to draw that same vector that would look like this attached to the end of the plane, so it's going to look something like this. I'll label that with an 80. Let me go back and label this one with a 500. Okay, for the plane. So that's traveling. Remember that this is going to be, that's at like a 45-degree angle here. So if I draw this, I've got a 45-degree angle here. Okay, and I'm looking for the x and the y component. So this is going west, that's backwards in the x direction, and it's going north, which is forward in the y direction. And if I use my cosine and sine, I end up with, in the x direction, which is west and backwards, a negative 40 rad 2. In the y direction, which is north and positive, I end up with a positive 40 rad 2. And then there's nothing vertically, so I've got negative 40 rad 2, 40 rad 2, 0 for the crosswind vector. My last vector affecting this plane is the vertical updraft of 30 miles an hour. Okay, that's not moving in the x direction, not moving in the y direction, and since it's an updraft, it's a positive 30. My resulting vector of my plane, now I didn't require you to do a drawing of this, but I thought I would show you the drawing just to make sure my resulting vector is going to be something like that. Okay, and the way I get the components of that resulting vector is by adding all three of these up. So I end up with a negative 40 rad 2 in the x component, a negative 500 plus 40 rad 2 in the y component, and a 30 in the z component. So that was the first thing I was looking for, were the components of the resulting vector. And then if I want the speed, I'm looking for the magnitude of that vector. So that's negative 40 rad 2 squared, negative 500 plus 40 rad 2, quantity squared, and 30 squared. And if I do that and I take the square root, I end up with an approximate speed of about 448 miles per hour. And that is problem 4. All right, guys, last problem here, problem number 5. You only needed to do part A or B, but I'll show you both. Part A was to find the torque exerted by the force vector negative 366 at an angle of 60 degrees with a radius or length of a wrench of 0.1 meters. So the magnitude of torque is going to be the magnitude, of the force vector times the magnitude of the length of the wrench, that magnitude of R, times the sine of theta. So all I'm doing is plugging in. First thing I need to find is the magnitude of the force vector. Writing R. The magnitude of the force vector is going to be the square root of negative 3 squared plus 6 squared plus 6 squared. That's going to give me a magnitude of the square root of 81, or 9. So when I go to plug in, I end up with 9. I already have the length of the wrench is 0.10, and then I have sine of 60 degrees, which is rad 3 over 2. So that becomes 0.9 times rad 3 over 2. And if I approximate that, I end up with about 0.78. Now my units here are Newton meters or joules. Okay, because my force was a vector in newtons and my radius was meters. Okay, so part A, if you did part A, was 0.78. Part B had a force vector of negative 122. We were looking for the work done by that vector at an angle of 60 degrees for a distance of 10 meters. Work is force dotted with distance. Torque is a cross product. Okay, I didn't write this here, but torque is force crossed with R, right? Work is force dotted with distance, which is the magnitude of the force vector, the length or the magnitude of the distance times the cosine of theta. This was 11.3, torque was 11.4. Again, I need to find the magnitude of the force vector, so that's going to be the square root of negative 1 squared plus 2 squared plus 2 squared, and I end up here with the square root of 9, or 3. That means that I've got a magnitude of a force vector of 3, a distance of 10 meters. There's my newtons, my meters. I'm going to end up with Newton meters here as well. And then cosine of 60 degrees. Cosine of 60 is 1/2. So I end up here with 30 times 1/2, or 15 joules, or 15 Newton meters. And that is problem 5 and the end of exam 3.